Hello everyone, my name is Aqib Javaid. I'm from Electrobit Automotive, and here I will be doing presentation with Stewart Hildebrand, and you are
Yeah,
from
uh,
AMD,
st-
so I guess most of people know him. And there is a one more participant, but unfortunately Rose is not here, but working on this talk with us with this, and the talk is about alternative P2M on ARM64. And this talk is just a sequel of our previous talk, which we have on Xen Summit in winter, which was about Xen to be Linux is used in a safe environment, Linux for safety application on Xen. And I will give let's go to agenda. I will give you a recap. If you guys were there, then you might already know what was it all about. Then we will see what we did this year so far.
Check, your mic is muted. I'm sorry, I think we must have pushed a button on there. Sorry to interrupt you.
No worries.
okay. Now I hear. Yeah, it works. And also, what were the main challenges which we faced? And then, there's some new features we added during this year. Also, some bug fixes. And then we created a demo, like how to prove that it works. And also about future work and path to upstream. I guess Stewart will also go through all this about it. So let's get started. We are already 6 minutes, but yeah. So I guess there is a one more talk after us. So I'm not keeping you away from the lunch. So I'm not guilty. So let's start with a recap. Uh, so at Electrobit, we had also, I guess at this very beginning, Cody also mentioned it will take a very long time to Linux to be safe, because in automotive, high performance compute and HPC platforms, everybody wants to use a rich operating system, which has a big ecosystem, all the tool stack, all the hardware support, and all these things. But to qualify Linux is a very big task. So we tried a different approach. We used like a two layers approach. We used a hypervisor, and also at the same time we use a safety monitor running in the hypervisor. So there is a hypervisor layer which provides the second stage page table for the Linux operating system. Then there is a safety monitor which is running in the hypervisor and monitors, the safety critical data is protected from the general purpose software. So this approach, it's not just approach, we did tried it, work it out, and also we got the TÜV stamp. So we have the safety qualified already solution from TÜV suite. So this is like a basic concept. Is there is a hypervisor, there is a this, but then we said, okay, we tried with one hypervisor, but we wanted to use with others. So then we start working with Xen. And how does the Xen comes into the picture? We were talking to Xen community, then Xen is also working with the safety qualifying the Xen hypervisor. But the main thing is they have now in the safety concept, there is a DOM zero less configuration. So you have user domains, but then you have a control domain, there's a hardware domain. And then we were when we were sitting together and thinking about it, we said, why not run this safety monitor in the control domain? And we figure out, yes, we can do it. And then we were second thing, which was really important, was us having capability in the Xen to have multiple stage to page table. And then we realized this exists already on x86, but does it exist on ARM64? And to our surprise, it also exists on ARM, but on a research fork. It's not in upstream. It was not in upstream. It was just on a research fork. There are two, on the research fork, it's publicly available. It's for Tamas and Sergey. We figured it out, and we said, okay, that's it. We have everything. Now we have to just work it out together. That was the state in the last winter. So that's where we left off in the last winter, and then we start doing it. So I will go through it because if it's just in a fork, what could be? We thought, okay, it will be a very straightforward challenge to make it work with the latest upstream Xen. Uh, I mean, there were a lot of challenges which we faced because this research work on ARM64 for alt P2M or alternative P2M was from very old Xen era, from 4.11 Xen release, and it was also not considering DOM zero less configuration. This was hope, but there was a lot of changes in the same time in the Xen. There was a restructuring of the P2M code, so more MMU specific code was moved to MMU directory structure, and also there was also a lot of because in the earlier, the research fork, it was expected that whenever there is a fault, it goes to, there is a VM event, and there is some control register, like a controller who is responsible for this. But in DOM zero-less configuration, it's not such, like there is no tool stack, so there is nobody. So like the idea was needs to change something. But our goal was same, that we want to adopt it to the latest Xen release so we can use the DOM zero-less configuration. And also, we wanted to have like automated tests as I set up, like, hey, it's keep working with all the release. So we said, okay, let's also introduce some test setups in our XTF so that we can always, that all P2M on ARM64 is always working. So that was our goals, and that was our problem statement. So this is the work by numbers just so far, just a really high recap. Like we worked on the Xen. So mostly there are like 39, but it's most of them are just rebase or like fixing of the commits on the like rebasing commits, resolving the merge conflicts for the research forks. There was like major changes to VTTBR, like a virtual translation table register, also fixing of allocate and this. Also there is like, of course, if you have to port the old P2M on the like our Xen, then we have to port all the stubs for HVM operation. There was some like little bit changes happened in the Xen latest release, like for reference counting, we have to adopt it. Then there was like an extra feature we added, like rated skip. I will go through a little bit more detail. But this is just a very high level recap what we did. And for XTF, which is more like for testing, so it's not about changes, but also like, of course, there were some missing features which we need to add in XTF ARM to make it work with it. So as I said, like I will just give you a little idea. What was the first big challenge was that, okay, the research fork was for 4.11 kernel. Then we want to do with the latest one. There was a lot of code restructure. The major one was the P2M code, which is normal. Not all P2M code went through like changes from like there was a code before one directly, like it was in Xen Arc ARM, but now it's moved, MMU specific code was moved to MMU directly, and then like common was in there, which is a good thing. I think like it's a good approach, but of course we have to adopt. We cannot just take the commits, all commits, and just rebase and use it. So we have to work it out and look it very carefully which needs to be. So there was a clear, a lot of work for the migration. And also there was a lot of functions, signature was changed, some headers were moved. And also, so it, like, as you can see that here, the old structure was just one file, and then you have like a different files, MMU specific, common, and new header. But we did it, like it was a work, but it's not like something which was causing us like some impediment or something. So it was just a work, we have to do it. Then other challenge, as I mentioned, that the previous research fork was mostly for considering in mind that there will be some like DOM zero running. Always, this was like a unwritten assumption. But now we want you to run in automotive like more like a DOM zero less configuration where our safety monitor is running in control domain. And so like what happens in the previous one was that whenever there is a memory fault, like with the old P2M, there is a VM event, memex was fault and VM event, and it was sending to like to your tool stack to resolve the fault and do whatever if you want to do it. What we wanted to do, we wanted to have there is a memex fault, we define the policy, and the policy will dictate what action needs to be dated. So we have to do this. And also like in DOM zero less, tool stack was like in DOM zero, we wanted to enable it at boot time because in DOM zero less, you have all the domain controls when you are booting, and you define all the domains in your device tree. So what we did, like first we created like a DOM control, DOM control like that it enables, like, so you can see in here, so you can in device tree, you just define all P2M. So 2 means like it's external, all P2M, the controller is outside, and then you define how many counts you want, how many maximum you can have like views of the sections. So you can define this, and during the DOM creation, it will go through, parse through it, and it will enable it all P2M for that specific cast. Also, how many all P2M possible counts could be. So that's how we achieve this. Then there was one other issue because it was this issue. Once we understood this issue, it was very straightforward. But the point was to figure out what was the issue. So in the Xen hypervisor, whenever like there is like a how many times a page table entries reference is used by reference counter, like for L2 and L3 page table entries. In old P2M, it's like used when you create a new view, it's a lazy copy. It's not like you just copy at exactly at the moment. It's just like a duplicate of the same page table, which is the previous one, or the host P2M, which if you want to call it. And when you change the page table according to your requires into the new views, it only happens when you do the first time access of the memory. So if if we like if it's a lazy copy, that's all. But we don't want each time the reference count is updated when you are modifying the page in the other views. So it was not straightforward to figure because previously the reference counter was different at different place and not in the old P2M view. So what we did, we added a host P2M check guard whenever there is a reference counter is updated. So like if it is the P2M is the host P2M, only then the reference counter is updated, and it's less. Then we were not having the trouble of having wrong reference counter. Other than that, there was like some VM ID allocation signatures were like there was some P2M allocation VM ID signature header was changed. Then there was some like also some functions and variables name was changed, but these were like very small issues at the time we fixed. It's just to mention like these things needs to be done. One more thing, as I mentioned that what we wanted this thing like previously like a normal old P2M, like if you have active, so if there is a guest who does the access violation, it posts the domain, like normally Xen was posting the domain and sending it to like controller to take the action. The controller can decide, hey, just it's a violation. I can allow it or I can disallow it like this. But what we wanted it, like we wanted to define a policy like, hey, you can define it like also at runtime what you want to do. And what, for example, it's a very common that in your safety set, like you don't want to allow if somebody, if there is a protected page, and if somebody's trying to write to it, you can monitor it and you can just say, don't allow it. So what you can do, you can define a policy. Okay, if access is like, there is an instruction to write on this memory page, you just say, okay, it will skip it. So what we do in ARM is that if you define this policy at boot time that, okay, this is the old P2M configuration, and then what happens when you try to write, a guest tries to write on some memory page, which is not allowed, it will just skip it. So by silently, the guest will even not know the write will never happen on that memory by just increasing the program counter by 4 bytes, which is like an ARM instruction size. And this is the way you can do it. And also, this is just by, if you define the flag that this will happen. Otherwise, it will just stay with how the old state is, like a legacy, it's still followed. It only if you define this flag while you are creating the old P2M view for that domain. So we're still on time. Yeah, so now XDF. XDF on Xen is also in a very tricky state, like because XDF on there is a XDF branch and there is a XDF ARM branch. So R for ARM, XDF is a separate branch. But it is missing many features for ARM. For example, while we said, okay, like we said, okay, let's write some tests to verify that all P2M now. We have done the rebase. It works, but we should write some automated tests. So first thing we realized there was some, currently in the mainstream, there are bugs in XDF ARM. For example, there is like architecture ARM expects, like it's taken from x86 and it's like the value of vCPU is defined 32 there, where ARM expects 1, so which creates a cascading issue. Then you have like a vCPU info wrong. Then if you are creating event channels on XDF ARM, it will not work right now today's state. So we were doing using the event channels, and while we were writing the test, we figured out it's not working. So we figured out like one by one, okay, event channels are not working. Somehow the vCPU info is not correct. Then we realized in XDF that this hash defined was not correct for ARM. Also, there were some missing features, for example, grant table, and I guess AMD helps us like, hey, we have a patch set, but it's not in a mainstream for grant table on ARM for XDF. Then same for the missing event channel operations. A lot of missing channel events operations are not on XDF ARM branch. So all these things were missing in XDF ARM branch, which we need to add it to run the tests for all P2M. Other than that, we added some like more capabilities to it. As for example, we added in Xen this feature of skip on violation. So we have to add in the XDF as well. And also we have to add some like small tests to control it. So that's like main thing we did achieve in the XDF. But now like we created like to create a concept around it to demonstrate that why it's important and why it works. So we took like, okay, let's start with the very simple, so which everybody can try. It's open source demo available. I have links available in the slides. So you have a Aqib setup, which starts U-boot, which starts Xen hypervisor in DOM 0 less. And then you start like in DOM U, you start just like a Linux, very simple setup, busy box, some kernel modules, and that's it. And you start in like capability 0, so it's a DOM U. And then in the control domain, we just start XDF and a small test. And in this test is not actually a test, but it's like, it's not, normally the test in XDF is like they run and they finish. It's not, it's just running all the time. So it's running, what it does, it's enable Alt P2M for that DOM 2, and it create a protected view and toggles protection. So a DOM to toggles protection, I will explain how this toggling will work, but this is just a basic setup. So there is a control domain with XDF test running, and then in the user domain, there is a Linux guest operating system running normally like this. What we want to do where we have like in the previous talk was Linux kernel, we say it's not qualified, but we want to run safety Linux application. So we want to protect the safety application running on top of it from Linux kernel itself. So that's what we want to demonstrate, that if there is a bug in Linux kernel drivers, how does the data in the safety application will be protected. So that's the main idea behind the demo. Also, like what we said, okay, let's take some, like there is a memory pages in the safety application, which is running on it. There are 2 pages just for demonstrative purpose. One is shared, like Linux kernel is supposed to write and provide information. So you talk to the driver, you say, drivers, please provide some input and data there. The other page is like, which is protected, and you don't want anybody to write it. You want to use internally. It's a critical data. So that's the idea behind it. So one is unprotected and one is protected. In Alt P2M, what you will do, you will tell in the different view, hey, make it read only. And in one, it says read write. So when the application is running, it will be both read write capabilities. But when you switch to kernel, you switch the view of the Alt P2M as well. So now when the Linux kernel is running, it's only read only this data. So without protection, application will write just for demonstrative purpose some string in one protected page and asks like some driver via ioctl, please provide me in another page some data. There will be a bug in the Linux kernel module. It will overwrite it and write also to the other page, which is not expected. What happens with the Alt P2M protection when you write your Alt P2M? This is for demo purpose, like we said, and you goes to the Linux kernel, but you do the context switch to the Linux kernel. Normally, when you go talk to the syscall, ioctl, or any syscall, you go to the Linux kernel. And then we just, for demo, like we had like this, there is a pre-syscall notation and post-syscall. So you can pre-syscall, we inform the DOM2, we are doing a context switch. So please change the view of the Alt P2M. So it will change the Alt P2M view and then go to the syscall. And because it will pause the domain, change the like a view and go back to there. And then when Linux kernel bugs will try to write it, it will just skip it on violation. And so your data will be protected, and even like protection will just work without causing any issue. So this is like just for demo purpose, like you have like a start of XDF, which says, okay, I started, I found DOM2, I created views, that's it. And then it just stays in a loop. Now it just waits. I start like a simple application in Linux, and I say, hey, this is my protected page. Unprotected page is this. Please tries to talk to the Linux kernel drivers. Please populate this data. It populates it and provides some sensor information, something this. But when it tries, the application reads its protected data, this is corrupted, which was not expected. But normally Linux kernel has all the memory access, so it can corrupt the Linux application, and this is where we want to avoid that. We want to protect our data from Linux kernel itself. Now, in where we have long protection enabled, the same application tries to run. It does the same thing. Say, oh, please provide me at this place some data to the Linux kernel. What happens now as we have like this, like we have a protect module there, it will try to communicate with DOM1, which is like as I said, like it's a demo app running in XDF in control domain, which will change the view, like a restricted view, and goes back to unpause the domain. Now, when the data will occur, like the Linux kernel will tries to write it, it will just skip one violation. And then you try to go back to your application. It will again change the view. So now you can rewrite your application back. So it's a pre and post, before and after context switch. And then now you can see that the bytes are there and that string is still protected. So that's the idea, like here, always using our P2M, you can protect the data from Linux kernel itself, and you have your application, it's like you can have a guarantee by Xen hypervisor that it will not be violated. So key lessons is the main thing is like for us is that if we have a research fork for old P2M, if we don't mainstream it, it will go a lot. Like we have to, like we cannot, it's an important feature we should have for ARM. It's x86 already exists. We should have it for ARM already available. And I guess there will be like, we will try next, soon we will try to create like, start working. I guess Stewart will go through further about it, what we want from community and what we want to do. So maybe like, I guess you will continue, you have this.
Yeah. Okay, thanks. Yeah, thank you, Aqib. So just at a high level, at AMD, we're collaborating with Electrobit here to provide just a really powerful software stack with a safety story, with Xen included, Linux included, so customers in the automotive space can use this and run Linux applications in a safety environment. Excuse me. So at AMD, we're working on achieving safety certification for Xen. We have a safety concept approval, and we are under Stefano's leadership. We were more or less all hands on deck to develop all the safety artifacts, and I know there are other players who have interest in making this happen too. So that's why Cody mentioned the safety membership, right? So there will be these safety artifacts available through the safety committee. Thank you. Okay. We're targeting both x86 and ARM. On ARM, it's 26262 ASIL D or 65308 SIL 3. On x86, it's a slightly different ASIL level. And as Aqib alluded to, and as many of us know, maintaining this in a downstream is just not sustainable. So we're tightly collaborating with the community and getting everything as upstream as possible. And we've done a lot of work so far, and particularly as far as Mizr C goes. There's a Mizr C, what do we call it? A tool that checks the compliance in the upstream CI loop. So. And a big thing we're working on at the moment is coverage testing. We have to test every single line of code that is in the safety configuration. Thanks to kconfig, we can choose, we don't need everything. For the safety configuration, we can down select, and that helps with our coverage. So, all right. We don't want to maintain a research fork, right? We want to get alt P2M on ARM upstream. So, each of us are members of the community. I want to repeat the call to action as well. We need reviewers. I'm doing on every year on my goals, like I have a goal to do more reviews. So I mean, myself included, you know, each of us as members of the community contributing and reviewing. So that, you know, it's a community effort to upstream things. And I know we're at time, so I'll go quick here. Yeah, review and feedback. I think I'm gonna wrap up. So let's see. Do we have yes in the back? Question.
Yes.
Can we get the mic?
Question. I didn't see the hand. Perfect. Please.
Thank you. Nice work. We've been playing with introspection for quite a while now, but we never actually finished to move to upstream. I really wonder when, Stewart, we are happy to review, so anyone from the team will be happy to review reviewing in P2M changes and so on. Like Vova, Alexander, anybody, I will ask guys to look at it. And we probably need to have a session on XTF.
Yeah, I was just thinking that, you know, I wonder if we could have a design session to defragment XTF.
We actually, I think we will miss Michał hardly here, but yeah, maybe he can join us.
Absolutely.
Yeah. But do you have this published somewhere? Maybe on.
It's
I mean, it's blue. It's
so if it's a slide, it's a GitLab. It's available publicly. So XTF work and Xen both are available. It's in branches. In GitLab. But it's available publicly.
So P2M, do you have a plan when you will start throwing in patches after 4.22 or before?
I mean, okay, like so we also looked at the previous like a mailing list, why it was not like merged into mainline. I guess the biggest concern or nag was that right now the work was done more like HVM operations were separated from it. So it was not common with the x86. We are working to make just review the last time comments, not create another session. And then if we are, I guess, as soon, I guess, like end of April, we want to start
end of April,
or like earlier could be more early. But our goal is to start it as soon as possible this, because as soon as we are in a state, we think it's ready for, I mean, it's working, but like we want to be able to, that it's also x86 and we don't want to duplicate the code in ARM structured directive. We want to keep it common with XT.
Yeah, of course. It has to, as much as possible, you can move. You shall move to common. Yeah, exactly. Okay, we are most interested in, as you can imagine, in ARM. So yeah.
Yeah, sure.
Okay, so let's maybe plan for session tomorrow on XCF. Yeah, thank you.
Yeah.
Great idea. Thank you. Thank you.
Thank you.
Other questions?
Time for another question. Yes, thank you.
I have just a quick technical question. How is it when you switch the stage 2 page table? I mean, do they run with different assets, like the IDs? And then you have to flush the entire TLB, or how does it work? Is there like a performance issue?
Yeah, that was also a question in last talk, like about this. Like first, it's for this demo, it's like, of course, it's not taking care, but like we have, like, as I said, Electrobit, we have also a solution. We worked with this. And then of course, when it's not ACID, but you need like a VMID switch because it's not ACID. So yes, you need a TLB flush when you switch for this. Yes, right now there are optimization technique when you don't need to do it completely, but yes, you need it for because of different VMID. All P2M is like a feature of Xen. If it's not like it works on x86 and it's there also, you need to have some kind of feature, because of course, if you look from stage 1 point of view, you don't see any difference because it happens in the stage 2. So if you have already in your TLB buffer some memory, read it, you will think I have the right to try to write it. So yes, you need it like this kind of flash.
Okay, no, thanks.
Yeah, it's probably a very dummy question, but how do you know which pages you need to protect on the process? How do you know what thing needs protecting and what thing needs not? What how do you know what you need to remove from the kernel P2M?
Actually, like how we achieve it in a proper product was like safety app has to inform it. So which data I want to protect it. Here in the demo, we just hard coded for this is there for Xen for time being, but actually in the real product, safety app, you started, there is a start phase. You say, you could have my all data memory need to be protected. But of course, you have copy to user, you want to have some shared memory with the kernel.
Yeah.
So it's like a starting phase you define, your application define, or you could also, like there is another solution, you can just say like, when you start an application execution, you can go through the L file and you see read the data section of that application, and then you can just tell, okay, this all memory needs to be protected. So this is like more like a policy which needs to be defined while development of your safety application.
Okay.